Today we're starting 4.10, transforming linear functions. What we're going to do is look at equations and determine how the slope and y-intersect affect the graph of a linear function. A bunch of different vocabulary we're going to talk about. First one was a family of functions. The family of functions is a set of functions whose graphs have the basic characteristics in common. For example, all functions form a family because all their graphs are basically the same shape. The main shape is called the parent function. That's the most basic function. What we're talking about right now in linear, the parent function is y equals x, or f of x equals x. The graphs of all other linear functions are called transformations. Transformation is where we're going to affect the original graph. There are three types of transformations: translations, rotations, and reflections. The blue line, the f of x equals x, is your parent function. Your slope is 1, you start at 0. So for every x, you move up 1 y. What has happened between the blue line and the red line? How far did it move up? 3. All it did was shift it up 3. How about the green line? Moved down 2. And the purple line moved down 4. Those are all examples of transformations. Those are all translations. Again, the same problems. You notice that the slopes are the same. They're all parallel to one another. If you're just transforming something, it should be the same slope here. It's when we start doing rotations and reflections things change. This is pretty much what I just said about everything being a translation. They are all vertical translations. We're not talking about anything horizontal. It's just moving up and down. They're being slid. It's a slide up and down. The only thing that's changing for a vertical translation is if we had the original function of y equals x. If the b increases, it translates it up. It moves it up on the graph. If I subtract or make it lower, it goes down. So give me an equation. Y equals 5x. I don't want to do 50. Let's do 4. There's a reason why I don't want it too large. The calculator screen only goes 10 in each direction right now in the standard window. So here is the equation we just made up. How about if I wanted to translate it down? What could I write? 5x minus 2. If I graph that one, and here, I'll go back. If I go to the left here, this is now flashing. If I press enter once, it makes it a thicker line. The thin line's the original one, the thicker line's the translation. All it did was move down how many places? Did not move down 2. How far did it move down from the original one to the new one? Did not move down 4. Why 6? It went from positive 4 to negative 6. It has moved 6, or negative 2, sorry. It moved down 6 places. If I took the graph and I could actually count 1, 2, 3, 4, 5, 6. So looking at it, I don't need to graph this, but I can use the calculator to help me graph. What is happening between y equals 2x and y equals 2x minus 6? How is it being moved? It is being translated down 6. You pretty much already told me this one. What's happening here? It's going down 6. I don't know why I have 6 so often now. Those are translations. These are rotations. There we go. The difference between a translation and a rotation. A translation moves things up and down. A rotation, what it sounds like. It's going to turn the graph. It rotates it. How does it do it? The graphs of y equals 3x, 5x, 1/2 x. They are all rotations of y or f of x equals x. So what makes a rotation? What's affecting it? The slope. The y-intercept is the translations. The slope is your rotations. So if I change the slope, I am changing the rotation. Regardless of how it's moved up and down, the y-intercept is the rotation point. That's where I'm taking the graph and spinning it. And that's what we said. The last piece is a reflection. Here's the graph, f of x equals 2x in blue, and g of x equals negative 2x in red. The numbers are identical except for the one's positive, the one's negative. By changing the sign, you're changing the reflection. The only thing a reflection does, it's changing the signage of the slope. Y-intercept plays no part of it. So if I have y equals 5x minus 2, what's the reflection of that one over the y-axis? Nope. It's 5x minus 2, so what's the reflection? The reflection, the negative 2 stays the same. It's negative 5x minus 2. The only thing that changes is the sign of your slope. The slope changes. And the slope's what's attached to the x. The number out here only tells me up and down movement. The number that's attached to the x tells me rotations and reflections. I have this graph here. F of x is 2x plus 2. It has been reflected over the y-axis. And now it's g of x. How would I write g of x? I heard someone say it, negative 2x plus 2. That's it. If you reflect something over the y-axis, you just change the sign of the slope. What would this one be if I reflect the f of x over the y-axis? Negative 2/3 x plus 2. if I have the function f of x equals x, your basic parent function, and I have g of x is 3x minus a half. How could you describe that transformation? What has happened between f and g? All right, the slope has changed. What happens when the slope's changed? It increases. How much has it been rotated? Rotated 3 times. So it's been rotated by a multiple of 3. And it's also this number here. What does the number on the end do? It's the y-intercept. So it has been moved which way? Up or down? It has been moved down how much? Just moved down just a half, which is just a little bit. So it's been rotated by a multiple of 3, and it's been moved down 1/2. How about if I threw that on there? If I threw that negative out front, now you add on, it's reflected over the y-axis. Let's piece everything together. Trophy company charges $1.25 for a trophy plus 20 cents per letter for engraving. The total charge is given as 0.2x plus 175. Should be decimal. There, it's fixed. Why did I change it? What was wrong there? It said 0.2. Right. Here we're talking about 175 cents. That's what $1.75 means. I had pennies mixed with dollars. I had to make them the same unit. So I accidentally left 20 cents and put it 0.2 instead of 20. How will the graph be affected if the charge per letter is lowered 15 cents? It's now 15 cents per letter. What now happens? It decreased by how much? 5 cents. So what's going to happen to my graph? It's going to go down by what? Is it just going to go down 5? What's the 15 cents standing for? Was that my y-intercept or is that my slope? Slope. What does slope do? Rotation. So it's only a little bit different. The graph is rotated 5 lower. So it's 5 times less steeper, or it's so it's not as steep as it was before. Let me move this down. You have to think, what's that number? Is it the y-intercept or is it the slope? And that's what a lot of you just got caught up in, is just saying, okay, it went down 5 cents, the graph's going to be moved down 5. You need to think, what is this number? Is it my slope or is it my y-intercept? My y-intercept moves up and down, the slope's the one that does the rotations.